when I look at my semicircular ducts, note how they are arranged to match the types of movement we can have. These are my two chambers. What's going on with the nerve? This is my vestibular nerve. A vestibule stands for a chamber type area. Where's my nerve going? To the chambers. My nerve has to go to the anterior and posterior chamber. The chambers, anterior, posterior. Just said each one is going to have a patch, the macula, of cells. One in the upper, one in the lower. They are for either vertical movement or horizontal. Does everybody now understand that macula? Now, if I look at the structure that I now have for my semicircular ducts, the chambers, they're trying to show me where there's this little section that they're going to take and they're going to blow up for us. First thing to note, look at my nerve endings. The nerve endings are going to synapse directly onto the hair cells. Once again, I have what looks like a membrane, a gelatinous material that the cilia of those hair cells are basically projecting into. So I have this structure where it's really cool. I've got a connection to my nerve fiber. I've got the cells. I've got the cilia. I've got my little supporting cells. They are embedded into a gelatinous membrane. And in that gelatinous membrane, looks like there are rocks. Ever been told, got rocks in your head? Yeah, we were. And it's true. In this membrane, there are otoliths. Otoliths. All right? Basically, little pieces of bone. Little rocks. All right? Let me think about this for a second. That membrane that contains those rocks that can come into contact with the little cilia of the hair cells, which are connected to the nerve, and they detect either up, down, side to side. What does it look like those little rocks, those little otoliths can do?
Trigger stances on the hair cells. I mean,
Why?
they bump into the hair cells.
Why? What's happening for them to be able to affect that hair cell?
Changes in orientation.
My changes in the orientation. As we move, those rocks, those otoliths, shift around. As they shift around, that means they are in contact with those cilia that are embedded in that membrane. And if they move them, they're attached to the nerve fiber, which means we've started an action potential.
So does this explain why you get dizzy when you spin a lot?
Yes. For example, let's go with the spinning. Like if you sit in a chair and you just twirl, 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 okay? Because this membrane gets moved in the different directions that we go, it takes a few seconds for the otoliths, the little rocks, to basically stabilize. So as they are still moving, they are still pressing on the cilia. And you still get the sensation that you're moving. Any of y'all, when you ride the elevator, go up, go down, and maybe, I don't know, it has to stop on every floor. Say you're going from the 6th floor to the 1st floor. By the time you get there, you're still doing that number? No? Just me? Okay, that's nice to know.
You got more rocks in your head.
Well, my rocks are probably not catching up very quickly. Can you think of any other way this might affect someone?
Like when you get off the boat, you're on the boat for a long time.
It can, yeah. Can you think of a way that this could actually affect a person's everyday life? To the point that they could actually be incapacitated. Vertigo. Everybody familiar with that? Okay, ever known someone that has it and has it so severe that they may not, they could be like taking medicine. Lots of things to that effect.
So I work in home care, and I get a lot of people who come in and get like these cervical collars for like they call it a crystal alignment procedure. Is that this stuff? Where they're talking about aligning crystals in the inner ear? They call it a crystal alignment procedure.
But what are they having?
Supposedly the doctor tells them that they're aligning crystals in the inner ear. It's supposed to be for vertigo.
A collar on them?
You put the collar on after you get the procedure done.
Did they send them to physical therapy for that to be done?
Mm-hmm.
Yes, that's what's happening. They have now learned that physical therapy can help in some cases of the vertigo that's very severe. And I think what happens is you go, actually heard on the radio yesterday an advertisement for one of the physical therapy places that we have here in Richmond, and the person there that specializes in this to help people with their vertigo. Thought that was pretty interesting because, if you've ever known anybody that has suffered from this, it can be very severe. And they were like all the success that they've been having. Basically, I think what happens is they kind of like, bend them in different directions. And I think the overall effect is equalizing out the movement of those otoliths and the membrane. And that's probably what they're probably calling them the crystals. Because that's what they do. They look like these the little things that are in the membrane.
Now, these membranes just the white part on the larger picture there, or are they the whole up top?
Up top, yes.
They're just the white outer ring.
This structure you see right here would be this area going around. So, pretty cool for equilibrium. So static you know, like as you're just sitting here, maybe just taking the notes or whatever the case might be, not a whole lot of movement, all right? But once you get up, take a break, come back, that sort of thing, depending on if you got on the elevator, up, down, all this sort of stuff, and luckily you're not falling over because your membrane with these otoliths and having the connection for that vestibular nerve, we're creating our action potential that will go to areas of the brain for our place in space. Do you remember what else in our body contributes to our place in space?
Sight.
Sight's going to play a part in that, but do you remember anything else that we may have talked about throughout the body? Proprioceptors, things that are embedded in the joints of the body. They're also sending information about our place in space for us to maintain our upright stance. Because in the grand scheme of things, technically we should not be upright. No. We've had physical adaptations that we use to be upright, but it takes a lot of muscles for us to maintain our upright stance. And they need to be receiving a lot of information. The other type of movement that we have is rotary. Turning around in a circle. All right, some people like that. So we're going to find that we have, once again, a cell that can pick up that information. Within those hair cells and those chambers, we've got this cute little structure. Kind of looks like, you know, a little torch somebody would carry. It's called the crista ampullaris. Same principle applies. We have our cells connected to the nerve. Basically, those cilia, once again, are embedded into this gelatinous type material. As we begin to twirl, flip, whatever the case might be, fluid pushes on them, pushes against them. They send their signal and able to keep yourself upright. People who do when I think about that part of our movement, for some reason I always think about people who do like figure skating, and they can do that twirl like 50 times, all right, and still be, when they're done, all right, and I'm just like, oh no, I would probably be laid out on the ice, you know, just like,
Wouldn't even be able to get up in the air.
yeah, but wonder when she's going to get up. It's just amazing to me how they can do that, you know, so it's kind of cool how those semicircular ducts work to keep us with our equilibrium. Any questions? Brian?
So, I mean, we talked about the like little vestibules, little chambers, but what is the significance of the actual semicircular ducts that are connecting them all? Is it one fluid that runs through it all and it's kind of all communicating with one another?
Right, so you would see fluid being in here, and here, and here, and here.
Is it a self-contained